Your machines are already generating data. Every second they run, every PLC, every sensor, every drive and meter on the floor is producing values constantly. For decades, almost all of that data lived and died inside the panel. Nobody ever saw it. IoT is what changes that. It is the term behind Industry 4.0, smart factories, and predictive maintenance. And underneath the buzzwords, the idea is simple. In this video, I will explain what IoT actually is, how it differs from the consumer Internet of Things in your home, the architecture, layer by layer, and where a PLC person fits in all of it. Let's start with the plain idea. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC networking and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the data. So what is the industrial Internet of Things? Strip away the marketing, and it is one sentence. Connecting your industrial assets to a network and the cloud, so the data they already produce can actually be used. The assets are the things you already know. PLCs, sensors, machines, drives. They have always generated numbers. The problem was those numbers stayed trapped in the controller. IoT collects that data, sends it somewhere, and stores it. Then it turns it into monitoring and analytics. Instead of a value being read once and thrown away, it becomes a trend you can see, a history you can search, a signal something is about to go wrong. That is the whole premise. Now, the distinction people get wrong. IoT versus consumer IoT. A smart bulb, a doorbell, a thermostat. That is the consumer Internet of Things. Convenient, and if it fails, you reset it. The industrial version raises the stakes on every front. Uptime is measured against production, so a drop connection can cost real money. Security matters more, because a breach can stop a whole line, not just annoy one household. The hardware has to survive heat, vibration, dust, and electrical noise that would kill a consumer gadget. The scale is far larger, thousands of points, not a handful. And it has to integrate with legacy equipment installed long before the cloud existed. Same core idea, completely different requirements. Here is the architecture, layer by layer. At the bottom are the field devices, your PLCs, your sensors, your machines, the things actually doing the work. Above them sits an edge gateway. It collects data close to the machine and pre-processes it, so you're not shipping raw noise to the cloud. From an edge, the data travels over industrial protocols built for this exact job. The two you will meet most are MQTT and OPC UA. MQTT is a lightweight publish and subscribe messaging protocol. OPC UA is a richer standard that carries structured, self-describing data. I have separate videos on both, link below. And from there the data reaches the cloud, where dashboards and analytics turn it into something a human or an algorithm can act on. Now, the part that justifies all of it, the payoff. First, predictive maintenance. With the data flowing, you can spot a bearing or a motor trending toward failure before it actually fails. You fix it on your schedule, not at 3 in the morning. Second, OEE and live dashboards. Overall equipment effectiveness stops being a number someone guesses at once a month and becomes something you can see in real time. Third, remote monitoring. You can watch a plant from anywhere instead of standing in front of the panel. Better uptime, less guessing, faster response. That is the practical reason companies invest in this at all. And this is what people mean by Industry 4.0. Not a single product, a shift where the machines on the floor become connected and data-driven instead of isolated. Here is the part worth hearing if you work in controls. All of it sits on top of the field layer. The PLCs, the sensors, the wiring. The cloud dashboard is only as good as the data underneath it. So the person who understands the field devices sits right at the foundation. How they are programmed, how they are wired, what the values mean. The whole stack rests on that layer. IoT does not replace the PLC engineer. It makes that knowledge more valuable. So here's what to walk away with. IoT is connecting your industrial assets to a network and the cloud, so the data they already produce becomes decisions. It is not the same as consumer IoT. Uptime, security, harsh environments, scale, and legacy all raise the bar. The architecture goes field devices to an edge gateway, over protocols like MQTT and OPC UA, up to cloud dashboards. And the payoff is predictive maintenance, OEE, and remote monitoring. The core of Industry 4.0. Get that, and the buzzwords stop being mysterious. Now, go make it concrete. If you want to practice PLC networking hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.